Blower doors like this one are among the most useful building diagnostic tools. They're used to track down air leaks, certify houses as part of home performance programs, and their use will soon be required for testing of homes subject to the 2012 IRC. We recently had Larry Armanda, a BPI certified blower door instructor, do a test on this 2,500 square foot wood frame house built in 2001. Let's see how he did it.
To prepare for the test, Larry turns off the heating and air conditioning system and any appliance with a flue. This step is important because the blower door's powerful fan could suck exhaust gases with carbon monoxide into the house during the test. Larry leaves his keys on the water heater as a reminder to turn the system back on before he leaves. Next, Larry walks around the house, closing and locking all the windows and exterior doors, including those in the garage. He opens all the interior doors and turns off any ventilation fans, like the range hood and bath fans. He also makes sure the clothes dryer is off. As he walks through the house, he looks for peeling paint, loose ceiling tiles, and anything that could be damaged or blown around during the test. He checks the fireplace for ashes. Now that the house is ready, the next step is to set up the blower door. Larry chooses a centrally located exterior door and unpacks the door components. He starts by assembling the frame and testing the fit inside the door opening. Then he lays the frame onto the fabric cover and secures the Velcro tabs. He reinserts the frame into the door opening. After routing the small green hose to the outside, he puts the fan housing through the elastic hole so the metal grill is on the outside. He confirms the fan controller is in the off position and connects it to the socket on the fan housing. He plugs the other end into a house receptacle. Then he connects the red air hose to the port on the fan housing and input port on the B side of the manometer. Now he connects the green air hose running outside to the reference port on the A side of the manometer. Larry makes sure all the flow rings and cover are in place so he can zero the manometer. Zeroing the gauge, also called establishing baseline, ensures consistent test results regardless of the weather outside. The process for zeroing the manometer is described in the manufacturer's quick guide. Once the baseline is recorded, Larry sets the gauge to measure in pascals and CFM 50. CFM 50 helps operators achieve negative 50 pascals even if the house is so leaky the fan can't depressurize it to that amount. Finally, he has to tell the meter which model of blower door the instrument is connected to. In this case, a Minneapolis blower door Model 3. Now that the door is installed and the manometer is configured, we can begin the blower door test. Larry starts the motor and slowly increases the fan speed until the manometer shows about negative 25 pascals. With the blower door holding steady at negative 25 to negative 30 pascals, he makes sure ash isn't being pulled from the fireplace or any interior finishes are in jeopardy of being damaged. Once he's certain everything is okay, Larry returns to the fan and increases the speed until it reaches negative 50 pascals. If he were unable to reach the minus 50 pascal benchmark, he'd remove a ring or rings and try again. If he still couldn't get to the negative 50 pascals, he'd use the manometer setting that extrapolates the current reading to minus 50. With the CFM measurement recorded, he then walks the house with the fan running to look for obvious leaks. A puffer, sometimes called a smoke pencil, is one common way to look for leaks. Larry also uses an infrared camera to look for air leaks. On this hot day, this ceiling register is almost 100 degrees because the blower door is pulling warm attic air into the leaky attic ductwork.
So testing revealed this home could benefit from some air sealing. At 6.2 air changes per hour, it's typical of its vintage, but a little work with a foam gun and some duct sealing would go a long way to improving its energy performance.